Okay, let's dive right in. Welcome to This Explainer. Today, we're going to unpack one of the most pressing yet strangely invisible crises of our modern era. Think about it. For decades, we've basically taken medical miracles completely for granted. We've got antibiotics, antivirals, antifungals, and they routinely cure diseases that used to be an absolute guaranteed death sentence. Ever since Alexander Fleming discovered penicillin, we've all felt pretty secure, right? But here is a wild piece of history. When Fleming actually won the Nobel Prize for that discovery back in 1945, he used his acceptance speech to warn the world. He explicitly said that microbes could easily be educated to resist the drug. He literally saw this coming from day one. And today, well, his warning is our reality. Suddenly, those medical miracles are actually starting to fail us. We are currently locked in a totally silent, incredibly high-stakes biological conflict. It's a true invisible arms race. So today, we're going to look at the hard data from the CDC, the World Health Organization, and some really cutting-edge genome analyses to figure out exactly why our medicines are losing their power and what that actually means for our future.
I want you to just take a second and think about this number, 1,270,000. And to be clear, that is not some worst-case scenario projection for the distant future. According to the Centers for Disease Control and Prevention, that is the staggering number of people worldwide who died directly as a result of antimicrobial resistance in the year 2019 alone. And it gets worse. If we look at deaths that were just associated with these resistant infections, meaning the infection was a major contributing factor but maybe not the sole cause, that number skyrockets to nearly 5 million. In the US alone, we're seeing over 2.8 million of these resistant infections every single year. So look, this isn't some theoretical threat waiting in the wings. It's an urgent, absolutely devastating global reality, and it's claiming lives every single day.
So that brings us to the million-dollar question, doesn't it? How exactly are microscopic germs defeating our greatest medical miracles? How is a single-celled organism completely outsmarting billions of dollars in human medical research and literally decades of scientific advancement? Well, the answer boils down to rapid, real-time evolution. Recent genome-wide analyses have captured this vast, incredibly complex network of cross-resistance interactions. In plain English, these germs are actively analyzing our weapons. They're adapting their own genetic code and finding absolutely brilliant, terrifying ways to survive environments that really should instantly kill them. To understand how we can actually fight back, we've got to understand the brilliant biology of our enemy first. Let's meet the superbugs.
Section 1. Meet the superbugs. Defining the invisible enemy.
Now, what's genuinely fascinating here is just how broad this threat actually is. Because usually, when we hear about this topic, our brains go straight to antibiotic resistance, right? We think of bacteria like strep or E. coli. But antimicrobial resistance, or AMR, is a way bigger umbrella than that. According to the World Health Organization, AMR happens when bacteria, viruses, fungi, and parasites change over time and just stop responding to the medicines designed to kill them. So this means our antivirals, our antiparasitics, and our antifungals are all on the chopping block here. For example, we're seeing deadly fungal infections like Candida auris popping up in hospitals globally, and they are completely unfazed by our standard antifungal treatments. When any of these microorganisms develop this resistance, they level up and earn the title of superbugs. They don't die when we treat them, they just persist in the body, they multiply, and they dramatically increase the risk of spreading to other people. All right, before we go any further, we absolutely have to bust a super common misconception. You've probably heard someone say this, or hey, maybe you've even thought it yourself. Man, I've taken so many antibiotics in my life, my body has just become immune to them. The most crucial thing to understand right now is that it is absolutely not your body becoming resistant. The CDC makes it so clear that antimicrobial resistance happens when the germs themselves mutate and defeat the drugs. Your immune system, it's perfectly fine. Your body isn't fighting off the medicine. It's the microscopic invaders inside you that have literally altered their own DNA. They're strapping on biological armor to make the medicine completely useless against them.
Moving on to Section 2, the germ defense strategy, real-time evolutionary warfare.
Let's look at exactly how these superbugs alter themselves. We're going to get into the tactical, honestly mind-blowing ways these microscopic villains engineer real-time defense mechanisms. Kind of think of this as a biological boot camp. Now, antimicrobial resistance is a naturally occurring evolutionary process, sure, but human behavior is pressing the fast-forward button on it big time. Here's how it plays out. Step 1, a population of germs is exposed to an antimicrobial drug. The drug successfully wipes out all the weak, susceptible germs. And honestly, it also takes out a lot of the friendly, helpful bacteria that normally protect our bodies. Step 2,
The rare germs that just happen to have a random genetic mutation allowing them to survive this massive chemical attack, they're left behind. And now, with all their competition completely gone, these resistant survivors multiply like crazy, taking over the whole environment. And then we hit step 3, which is easily the most alarming part. They can actually share these resistant DNA traits directly with other germs. They are literally passing around genetic survival instructions. It's almost like they're wirelessly beaming a survival app to each other via Bluetooth. And get this, they can even transfer this resistance to entirely different species of germs that have never even seen the drug before.
So what exactly are those genetic survival instructions doing? Well, the CDC tracks 4 primary defense strategies that germs use to fend off antibiotics or antifungals. First, they can restrict access by mutating and actually changing the physical entryways in their cell membrane so the drug just can't get inside. Second, they can get rid of the drug using literal mechanical cellular pumps. Third, they can destroy the drug by deploying specialized proteins called enzymes to actively hunt the drug down. And fourth, they can change the target, which means altering their own internal structures so the drug has absolutely nothing to latch onto. Let's actually zoom in on a few of these highly elegant, kind of terrifying mechanisms to see how they work in the real world.
Let's start with the pumps, because the biology here is just wild. Certain bacteria, like Pseudomonas aeruginosa, and certain fungi, like Candida species, have evolved the ability to construct physical mechanical pumps right inside their cell walls. If an antibiotic or an antifungal drug actually manages to breach the outer membrane and get inside the cell, these pumps activate immediately. The germ expends its own cellular energy to literally spit the drug right back out into the surrounding environment. It's exactly like having a microscopic bouncer at a club, just grabbing the medicine by the collar and physically tossing it out the front door before it can cause any trouble. And they do this at astonishing speeds, clearing out the toxic medicine way faster than it can even accumulate. And then you have tactics that are just straight up chemical warfare. Some germs don't bother gently pushing the drug away, they actively destroy it. Take a notorious bacterium called Klebsiella pneumoniae. It's learned to produce specialized enzymes known as carbapenemases. So when you introduce a really powerful, common class of antibiotics called beta-lactams into the environment, these enzymes act like a highly targeted missile defense system. They don't just block the antibiotic, they intercept it and physically shatter the molecule into completely harmless chemical pieces. The drug structure is totally neutralized before it even touches the bacterium, and the superbug just swims happily right through the chemical debris.
Finally, we have the biological disguise, or what's known as changing the target. Think about it like this. A lot of our most powerful antibiotics are designed like highly specific keys made to fit a very specific lock on the germ's surface. Key goes in the lock, germ dies. But what if the germ just changes the lock? E. coli bacteria carrying a specific genetic mutation called the MCR1 gene can actually add a brand new chemical compound right onto the outside of their cell wall. And because of this one tiny structural change, a drug called colistin simply cannot latch on anymore. The key just doesn't fit. Now, the reason this is so terrifying is that colistin is known in the medical world as a last resort antibiotic. When doctors use a last resort drug, it means the pharmacy is completely out of other options. So if the bacteria change the lock here, doctors literally have nothing left in their toolkit to save the patient. The target's been disguised, and the superbug wins.
Section 3. The spread of resistance, a global health threat without borders. So now that we understand the incredibly sophisticated ways these germs mutate down at the microscopic level, we really need to pull back and look at the massive, interconnected global crisis this creates. Both the CDC and the World Health Organization classify antimicrobial resistance as a One Health issue. What that means is human health, animal health, and environmental health are all deeply, intricately tied together here. A huge driver of this issue actually happens way outside the hospital, in agriculture. In a lot of places around the world, widespread antibiotics are given to completely healthy livestock just to promote faster growth or prevent illness in crowded spaces. And this agriculture practice pumps massive amounts of antibiotics right into the environment, creating a giant evolutionary playground for superbugs before they ever even come near a human patient. As the CDC puts it, modern trade and travel mean it can move easily across borders and can spread in places like hospitals, farms, the community, and the environment. A superbug that evolves in the gut of a farm animal on one side of the planet can travel into the food supply, hitch a ride inside a human traveler on a plane, and end up causing an outbreak in a hospital on the other side of the planet by tomorrow morning. We cannot ignore this because it literally has no borders. And why does this global spread matter to you directly? Well, because the cost of losing this arms race is almost unimaginably high. We aren't just talking about having a stubborn cough or a sore throat that takes an extra week to clear up.
The reality is, so many of our incredible, life-saving modern medical advances rely entirely on our ability to aggressively fight off infections. I really want you to let the gravity of this sink in. Without effective antibiotics, routine surgeries like joint replacements or C-sections become incredibly deadly gambles. Organ transplants? They become nearly impossible because of the immense risk of post-operative infection. Cancer therapy, especially chemotherapy, which drastically suppresses a patient's immune system, relies completely on a constant shield of antibiotics to keep those patients alive. Even just managing everyday chronic diseases like diabetes, asthma, or rheumatoid arthritis becomes incredibly dangerous when simple infections can't be treated anymore. If we lose antibiotics, we don't just lose a few drugs from the pharmacy. We literally lose modern medicine as we know it.
Finally, Section 4, Winning the Arms Race, Your Role on the Front Lines.
But listen, it is not all doom and gloom. Yes, the global problem is genuinely terrifying, but we are definitely not powerless here. Let's pivot and look at how we actually slow this down, starting with what you can do literally today. The CDC lays out several highly effective, actionable strategies to improve antibiotic use and stop these resistant germs in their tracks. First up, just prevent infections in the first place. Practicing basic healthy habits like consistent hand washing is a literal frontline defense that stops germs before they ever even require medical treatment. Second, and this one is absolutely vital, never, ever use antibiotics for viruses. Colds and the flu are viral, so begging your doctor for a Z-Pack when you have a viral flu doesn't just do zero for your cough. It actually actively trains your internal germs to become supervillains by unnecessarily exposing them to the drug. Third, have open, honest conversations with your doctor or your veterinarian. Ask them point blank, is this antimicrobial truly needed right now, or can we wait and see? And finally, always tell your healthcare provider if you have recently traveled internationally. This helps them quickly track and contain any global superbugs you might have accidentally picked up. You have a direct, vital role in slowing down this threat. Which leaves us with this final, crucial thought to chew on. The microscopic world is constantly analyzing our medicines. It's changing its DNA, it's sharing survival apps, and engineering new, brilliant ways to survive. The germs are adapting in real time. The big question for us as individual patients, as healthcare providers, and really as a massive global society is, are we? Are we actually willing to adapt our agricultural habits, our prescribing habits, and our daily health routines to protect these vital medical miracles before they're gone forever? It is an invisible arms race, for sure, but it is one we simply cannot afford to lose. Thanks so much for joining me on this explainer, and I hope this empowers you to think just a little bit differently the next time you reach for a prescription.